Hello guys, welcome back to the channel. Today we are solving another LeetCode problem, that is 2360 longest cycle in a graph. Before jumping into the solution, I would highly recommend you should read the problem statement on your own and give at least 15 to 30 minutes before jumping into the solution. So let's get right into it. What problem is asking? That you need to return the longest cycle in the graph, and graph is directed. That is pretty much easy. Let's understand it using a graph only. Wait a minute, let me just make it quickly. Also, if someone is not able to understand that how is this made, you are given this edges vector and you are given this is the indexes. Let me write it, index. So what we are doing, 0 to 3, 0 to 3, 1 to 3 a directed edge, 2 to 4 a directed edge, 3 to 2 a directed edge, and 4 to 3 a directed edge. That's how a graph is made. So back to our question, what we have to return is this, the path we have to return of the cycle, and or the number of nodes that we have in that cycle, this 3. We have to return this 3. If there was more than 2 cycles or many cycles, we have to return the longest one. That is clear, that you know. Let's get into the main part. Before jumping, you need one prerequisite. What is that? How to detect cycle in directed graph using DFS. This is a must know, but don't jump off this video. I will discuss it not in very detailed manner because I don't want to make this video hour long. I will discuss it the main part. For more understanding and all, you can watch it on your own. So the main thing is we use visited and visited path in this. So what does it mean? You know visited, but new thing is visited path. So while doing search for the cycle in a directed graph, what we see is that it doesn't mean that it is visited in the past, that it is forming a loop. For example, something like this. Let me change the pen. While a traversal like this, it was visited. These are already visited. Now in some other traversal, we mark this visited and path visited. Again, we went to this, we marked this as visited and path visited. And when we went to this, it was already visited. Then we check path visited. No, it was not path visited. So it means that this is not the loop. This is not the loop that we required. Because if you have done undirected one where we see if it is visited and we check if it is not apparent, but here we check if it is path visited, if it fall in the path, but it didn't fall in the path. It didn't fall in the path, but it was visited before. So that's why we are using path visited to know whether it is a loop or not. So this much is clear. And let's understand one more thing. Now we know how to find the loop, but this time what we need is return the size of that loop, the number of nodes in that loop. So one thing is for sure, let me make that graph over here. One thing is for sure, While traversing it, we have to store the number of nodes that have preceded, or the number of nodes, in order to get the length that is required. So how we gonna do it? We gonna do it using a current count variable and a count vector. We will store the count according to the node. Let me copy it. It will just waste time again and again making same thing. Yeah, so 1 0 2 4 3. So what we will do is, let's start from 0 only. This is your current count vector, and this is your not vector, variable, and this is your count vector. So when we are at 0, we have count 1. We went to 3, we have count 2. It is overlapping, both the things are same, but let me write it down. Current count is 1 2. Now we go to 2. From here we go to 2. Here again the current count increased, and we store it over here. Yeah, now we went to 4. Current count increased to 4, and we store that also. Now we again went to 3. Current count is 5. It is visited already. When we visit, it is visited already, but it doesn't mean that it will form the loop. We will check path visited, and as you can see in this path, 3 was visited. While going over here, 3 was visited during the path. It is the member of the path. So what to do? What we will do is, this is what we required. We have found the path, the loop, and also when this happens, what we need to calculate? The loop length. And how we gonna do it? This much is the unnecessary. What is unnecessary is that we have counted 3 2 times. Let me write it over here only. We have counted 3 2 times and 0 1 time. What we have to eliminate is, we need 3 2 4. We need 3 2 4, but we have counted 3 2 times. Delete this time. Delete this. How many we have deleted? 2. How are we gonna get this 2? As you can see, 2. How are we gonna get that 5? Over here 5. What is the loop length? You know what is the loop length? 5 minus 2. That is the loop length. That's how that whole algo is working. Now let me discuss the code, and I will dry run it because it will become a long video if I done the algo and again, because most of the code is that how to detect a cycle. Very few lines are added, so that's why it's most beneficial that I discuss the code only. Yeah, what we are doing, getting the number of edges, not edges, the vertex, making an adjacency list. Very basic thing in a graph problem. You know why we make this. Why edge minus 1? You should read problem statement, not gonna explain. And what is this? Visited, path visited, the distance over there, it was count. Here I took it distance, mainly same thing. And basic thing when we are encountering components, different components. And also why I did this total distance is equals to 0, because do you want to convey that total distance, that number of nodes to other component? No, you want a fresh start. That's why. Very basic thing. Then also I discussed it. Very basic loop, basic condition. If not visited, then only do the call, so that we cannot just iterate over the same component, different component also. Yeah, this is our max answer. Obvious reason we don't have to pass in the calls, and we can have this as void. Max answer total distance. Here is our visited and path visited. We made them 1 1 because obvious reason. Why I am explaining again and again. We are iterating adjacent node. If that node is not visited, what we do? Count the total distance or total nodes, save it inside the count vector. Why? I already told. Why I already sorry, I told what already, that when this thing happens, how will you get the count? Not through magic, obviously. So you have to store it somewhere. So you get that count using this. That's it. Now you keep on visiting. If something is already visited, then the thing happens. We have to check, is it path visited? If it is path visited, what we do? We increase the distance and we find the path length. How are we gonna do that? Total distance that we have calculated, or total nodes, minus the nodes that are already counted, and also the useless one over here. 3 was counted. Where is it? 3 was counted 2 times. We need only 3 1 times, and 0 was not required because it was not the member of that loop. I hope I am clear. And what we do, because we need maximum, that's why we are comparing with the current loop length. Very basic thing. And after that, what we do, we make it that path unvisited, because when we backtrack, we are no longer at that path. To understand that more, you can find more videos over how to detect cycle in directed graph using DFS. So this much is clear, I hope. And does it require a dry run? I hope no, but let me do it for you. Dry run will just make it this video long. Let's start from 0. We are starting from 0. This is visited, this is path visited, and 0th node, let me write it 0 over small. 0 is visited, also path visited. Let me have the graph also. Yeah, 0 is visited. Now we go to 3. So I also have to make this distance and total distance. Let me write it over here. Total distance here is 1. At 0, what is the total distance? This is 0. At 0 it is 1. Now we go to 3. Wherever is 3, it is visited. path visited at 3, distance is 2, not 2 the number of nodes, whatever you like, distance or nodes. Total distance is also 2. Now at when we get at to 2, so at 2 we make this path visited, we make this also visited, yeah, and also total distance is increased, and over here 2, over here 2, 2 is what it is, 3, 2 is 3. Now we go to 4, total distance is also 4, 4. It is coincidence that it is 4. It doesn't mean that we are just going with the value of node. Now at 4, distance is also 4, and we marked 4 as visited, 4 path visited also. Now when we encounter 3, interesting thing happens. Total distance is 5 this time, and it is visited. We get to this loop. What we do? We increase the 5. Now we find the path length, and also it is 3, 3. It is path visited, as you can see. So what we will do is find the path length. Path length is that 5 minus that, with 3 we have 2, minus 2, 3. We store it in the max answer, and that's how you do it. You can do for other nodes. Video will be very much long. Let's submit it and see if it is running or not. I hope it should run. Yeah, it is running. I hope I was able to make my intuition pretty much clear, and I hope you did learn something. And if you did, so please consider subscribing to my channel, liking this video and sharing with others. And you have to do what you have to do, so keep grinding, guys. Keep grinding, and see you in the next one. You guys are awesome. Bye bye.